I, Anshika Kumari, being your host for today's event, wants to extend a warm greeting and good afternoon to all of you present here. I hope you all are doing amazing. On behalf of the whole SEMS family, I welcome you all for today's international webinar on the topic Self-Reliant India. And to add our guest of honor and today's speaker, Dr. Neeraj Tripathi, it is a great honor to have you with us, sir. We are grateful for your presence. Also, I see a quite number of people are joining us. Before I proceed, let me take a brief moment for the introduction of the organization. SEMS Welfare Foundation. SEMS Welfare Foundation is a non-profit entity established to work in the areas of education, social welfare, women empowerment, skill development and entrepreneurship, livelihood generation and employability, health, research, culture, international cooperation, sports, environment protection, or any other similar sectors. We promote healthy lives, a balanced and active community, and strong businesses. Now, let me introduce you today's speaker to you all, Dr. Neeraj Tripathi. Dr. Neeraj Tripathi has 17 years of professional experience in education, skilling, HR recruitment, and career progression domain. Before starting with today's event, there are some ground rules which the participants need to obey and follow them. First is feel free to drop your question in the chat box. We will answer every question in the end. Second is every participant is requested to keep their mic on mute mode. Lastly, a feedback form will be shared in the chat box. Now over to you, sir.
Thank you, Anshika. Can you hear me? Can you watch my slides?
Yes, sir, it is visible.
So, good evening, everybody. Myself, Neeraj Tripathi. And today I will give a brief seminar on a very hot topic nowadays, semiconductor manufacturing and fabless designing. So, we will discuss something about semiconductor and we will discuss about fabless designing. And we will also go into the detail why we are so much focused about the semiconductor manufacturing now. So, because this topic is basically a technical topic, and I teach BTech students, and recently I got an opportunity to visit IIT Jammu, and where I saw that government of India is focusing a lot on the semiconductor manufacturing and fabless design. So we will go one by one. So the first question is, what is a semiconductor? So we all know in daily life, we daily need, we use metal, we use semiconductors. Metals are conducting wires, and we all know conductors. Similarly, we have materials which are insulators. The conductors and insulators are differentiated on the basis of their conductivity. Conductivity means whether they will allow the flow of electricity or not. So in simple word, we can say that metals are those materials which will allow the flow of electricity easily. On the other hand, insulators are those materials which will not allow the flow of electricity. We have a group of materials whose conductivity lies between these two extremes. Those materials are called as the semiconductor. So in summary, we can say that semiconductor is a group of materials and whose conductivity lies between metals and insulators. So we can say that semiconductors are neither metals nor insulators. For example, the basic semiconductor materials are silicon, germanium, gallium arsenide, and a very large number of materials are called as semiconductors. So in short, we should understand that semiconductors are a material and they are nothing new, but their properties are different from the metals and insulators. So now semiconductors can be of two kinds. One is pure elements. Pure elements, for example, silicon and germanium. These semiconductor materials are pure elements. On the other hand, we can have compound elements also. Compound semiconductor, of course. They are gallium arsenide and cadmium selenium. So here I would like to clarify why we go for compound elements. We go for compound elements to achieve different kind of applications. So the more applications we require, better semiconductor materials are needed. Now coming to this point, manageable conductivity and manageable. Imagine a situation, you have a copper wire at your hand. Once you have that copper wire, that is the end. I mean, you cannot change the property of the copper wire. Similarly, if you have wood, you cannot change the property of the wood also. But semiconductor materials are such amazing material that you can change its conductivity and you can change its property. And this behavior of semiconductor material allows us a lot of application of semiconductor materials. So why we go for semiconductor materials? Because we can manipulate their conductivity and their property. Now the question is why semiconductor is important. As discussed earlier, ability to change its property. You can change the property of semiconductor material easily according to the requirement. Other thing is that with the help of semiconductor material, we can design or we can fabricate special devices. We will see what are those devices. Other thing, however, the concept of semiconductor is new, but in last 30, 40 years, we have well-developed technology. Technology means how to get pure semiconductor, how to design or develop a semiconductor device. These technologies are quite mature nowadays. We will see that manufacturing of devices are very critical and you require sophisticated equipment. Nowadays, we have excellent equipment and we can use those equipment in order to manufacture semiconductor devices. The great thing about semiconductor devices is that you can come with innovative devices. Innovative devices means innovative applications. We can have devices which have totally unimaginable applications. Now coming to the more interesting part, semiconductor devices have a wide application area. For example, computer. Computer is purely based on semiconductor device. It is purely based on integrated chip. For example, electrical devices. For example, we are using nowadays in biology also. For example, your mobile phone is an example of semiconductor device or chip design. In ordinary world, we use the word chip designing. Chip designing is nothing but this semiconductor manufacturing. We also talk about IC, integrated circuit. If you open your mobile phone, you will be amazed to see that the actual device is very little. That is, integrated circuit is very small. The application of semiconductor is wide because over a period of time, we are able to reduce the size. 30, 40 years back, the computer was very big. Even in our life, we have seen that laptop computers are very tiny nowadays. We have mobile phones of a smaller size. We have spy devices of a smaller size. The semiconductor devices are becoming small and small. smaller actually, and this is a critical uh, this is a critical thing for these military devices. For example, we cannot reduce the size of a car. That's why we see that mechanical engineering is almost stagnant. Similarly, we cannot reduce the size of a house. So that's why we see that civil engineering is almost a stagnant side. And we should always remember that whatever we talk about fast communication, we talk about modern computers, we talk about mobile phones, everything is dependent upon the development of semiconductor devices. If you don't have semiconductor devices, nothing will be actually implemented. Everything will be in a conceptual level. Here, I would like to mention a very important point. Nowadays, we hear about artificial intelligence, we hear about IoT, we hear about machine learning. Well, these are computer area, we can say. But the question is, the concept is not new. We already know about AI, about machine learning 60, 70 years back. We had concept about the fast communication maybe 70 years back. But those concepts are being implemented now. Why? Because the hardware to support those concepts is available now. Now we have fabrication labs, we have manufacturing facility where we can design, where we can fabricate 3D devices over which we can implement IoT. Take any IoT device, you will find that that IoT device is nothing but semiconductor device that is basically integrated circuit. So now we can safely say, look around yourself, you have semiconductor everywhere. You will be amazed to know that when you get up in the morning and you reach to your office or school, you actually use more than 100 semiconductor devices, even more, and even without knowing them. Whether it is a car, your mobile phone, your cooking system, everywhere semiconductor is available. We will discuss why when semiconductor is so important, why government of India is so much focused in this field now. Well, we will see. We will explore and we will try to know the opportunity and we will try to know why this field is so important. Here are some of the applications of semiconductor devices. Just to give you a feeling, for example, a rectifier. Rectifier is a basic semiconductor device. You always use a rectifier in the form of mobile charger. A rectifier is a device which converts AC, alternating signal, into DC signal. That is what we do with the help of charger. For example, amplifiers. We use amplifiers daily, all the time. For example, if you want to raise the voice, the intensity of the voice, you use the volume. Volume controller is nothing but the amplifier. And we implement these amplifiers with the help of semiconductor devices. Computer CPU. CPU stands for Central Processing Unit. You can say that it is the brain of the computer. If brain of the computer is dead, computer is also dead. This CPU is nothing but semiconductor device. For example, memory. Many of us may remember that few years back, 128 MB memory will be quite larger in size. But nowadays we have memories in the range of gigabytes. The size is very small. The thing is, these memories are nothing but these semiconductor devices. Here I would like to tell a very interesting point. For example, Intel. We all know that Intel company, and we can see that we are using the Intel microprocessor in our computer. You will be surprised to know that Intel company was basically a memory design company at the beginning. But over a period of time, it converted itself into a microprocessor company and finally as a computer. Mobile phone chips. Mobiles are nothing but a chip. Electronic locks. Drone chip. Nowadays we talk about drone. We can see drone everywhere, but drone is possible because we have semiconductor. Likewise, robotics board, etc. All are nothing, but they are all the applications of semiconductor device. You just imagine, you will find that semiconductor is there. So now the question is there. There may be a question. What would be the growth of semiconductor in coming years? Why this is so important? Up to now, we can say that semiconductor devices are embedded everywhere. Since semiconductor devices are used everywhere, so this growth should not be a problem because we are using semiconductor everywhere. Therefore, the growth of semiconductor will remain for a very, very long time. Of course, in different manner, because we know that nowadays we are talking about disruptive technology. We are using technologies which are destructive in nature. Something which is very important today may be obsolete tomorrow. But it doesn't mean semiconductor devices will go anywhere. They will remain here, but they will remain in a different shape or in a different form. Maybe we will have laptop smaller in size. Maybe we have a mobile phone even more smaller. Maybe we may have 1 gigabyte or even 100 gigabyte memory, but size is very small. For example, USB, which we use every day, we call it a data stick, nothing but a semiconductor device. And we can see that the size of the semiconductor device is reducing every day. So why we go for the reduction of the size? When we have a smaller size of the device, it requires lesser power, lesser energy, and you will notice one thing that is very important. The cost of these semiconductor devices is also falling. We boast most of the time that everybody in India is having a mobile phone. Of course, everybody is having a mobile phone. But why? How is it possible? It is possible because the price of the mobile is decreasing. It is up to you whether you want to buy a mobile phone, I mean expensive mobile phone, or a workable mobile phone. Anyway, you can buy a mobile phone even more than 1 lakh, but you have mobile phone in the range of thousands also. So this is only due to the development in semiconductor. The other area of development of semiconductor is the fast communication. You know that now we are talking about 4G, 5G, 6G. All these things are possible only because of semiconductor. Because we have very improved semiconductor devices and we can use 3G and 4G and other things using those devices. If you don't have semiconductor devices, all the development will be halted. Coming to the IoT devices, as discussed earlier, IoT devices, AI devices, safety devices, automobiles, etc., are all semiconductor devices, and those devices are fabricated in labs. We should remember that we do not manufacture semiconductor devices openly. In order to develop semiconductor devices, we must have labs, we must have manufacturing center. And that is the theme, that is the point of discussion in this seminar, in this webinar. Similarly, semiconductor chips will be always used in computer, laptop, memory. Therefore, we will always need semiconductor devices. So what are the growth area for the semiconductor? As discussed, the growth of memory is immense, therefore the need of semiconductor is immense. The mobile phone is rising day by day. We need a fast communication, more fast communication. We want modern cars with a lot of safety devices. And you know that a simple car with some improved safety devices is expensive. Remember, all the control of the car is possible only due to semiconductor devices. One area where India is, is quite good is space application. So we all know ISRO has done a lot of good. In space application, electronic devices are used because electronic devices are used to control the trajectory of the mission. The other application area of semiconductor devices is the military application. We use electronic devices or IC chip in missiles, fighter aircraft. So we can say safely that the growth is immense. Now let us focus on this particular graph. This graph talks about manufacturing. So, as I told, manufacturing means labs, manufacturing means facility. Do you notice one thing? That being such a large country, we do not have any fabrication labs. See here. Where are those labs? America, of course, and China, some part of Europe. But India is nowhere. That is why government is serious. So India being a huge population, country, everybody is having mobile, laptop, cars, use of electronic devices, but we do not fabricate electronic devices. What an irony that we are consuming electronics, but we are not producing electronics. It is expected that if something is not done in coming 10 years, our import bill on a semiconductor will be larger than the oil bill. That is why government is under pressure to do something, in order to reduce our import bill. Here just so in short, if I want to summary, why semiconductor now? Because it is economics. We cannot afford to lose dollars. We cannot afford market. Therefore, government is very serious, and we should thank this government that they came with a semiconductor policy for the country. Well, here I would like to say that it is not that we do not have capability. There are some genuine problems, and those genuine problems we will discuss in this lab, in this webinar. What is semiconductor growth expected? Let us see the figures. In 2021, the global semiconductor market size was 527 billion. It is a huge amount. What is projected? It is projected that by 2029, it will go to $1.38 trillion. What is the rate? The exhibiting a CAGR, cumulative annual growth rate of 12.2%. That is a huge growth. In a consumer market, anything more than 5 or 6% is a huge success. For example, if you talk about Nestle, if you talk about ITC, if you talk about these consumer goods, their growth rate is not even 5%. But here is a field where the expected growth rate is 12.2%. Now see the last point. India imports 94% semiconductor from China, Singapore, Hong Kong, Malaysia. Forget about China. What about Singapore? Such a tiny country, Hong Kong. I am sure many of us cannot find Hong Kong on the map. Malaysia, they are a small country. I have not mentioned the name of Israel. India is importing semiconductors from these countries. Now let us see some facts for the Indian market. Before that, see the points. If semiconductor import will not control, it will surpass oil bill. We all know that oil bill is huge for India. So if semiconductor import bill is not controlled, we will be paying more for purchasing semiconductor. That is the reason electronic hardware manufacturing is the priority program in Make in India. Again, read electronic hardware manufacturing. We always talk about computer engineering. We always talk about all those things. Please remember, nothing is possible without this. If we do not have electronic hardware manufacturing in India, we will lose. We will lag in coming time. Now, coming to the data to understand the feeling. In 5 years, the semiconductor import by India will be $54.87 billion. It is a huge amount. $54.87 billion is a huge amount for India, and it will rise to 110 billion in coming years. So you can say that we are spending a lot of money, lot of dollars for semiconductor devices. That is why India has to. We do not have any other option but to develop our all manufacturing facility in India. That is what government is doing. So why semiconductor manufacturing is now in last 5 years? Here are some of the reasons. With the advent of 5G technology, semiconductors consumption in India is expected to cross US $80 billion by 2026 and US $110 billion by 2030. We have to compensate, we have to augment these requirements. That's why we have to produce at least, actually, I would like to tell that what we are expecting that at least 30 to 40% demand should be met by Indian companies. So in other way, by 2030, we are expecting that around $55 billion out of this should be met by the Indian company. We cannot meet all the demand, but let us focus maybe 50% demand. Looking at the present scenario, we can meet only 6% demand. 94% demand is met by the countries which we discussed earlier. This is the eye-opening. What happened in COVID situation? We all know that supply chain was stopped. Supply chain was disturbed. We still remember that many car companies were unable to provide the cars to the customer because due to China and Taiwan situation and due to this COVID, Taiwan was unable to provide semiconductor devices to the world. This problem was throughout the world, including USA, Europe, India, China. Car companies were badly hit. And this opened the eyes of the India. If we are not self-reliant in the field of semiconductor, we can be blackmailed by any country. And here I would like to remind when in 1998-99, India conducted atomic bomb, the first restriction was in the field of semiconductor devices. The next day, USA stopped all the high-end semiconductor devices to the India. So we use semiconductor devices in AI and IoT, and the application of AI and IoT have sparked a new wave of innovation in the semiconductor industry and launching of 5G network. All these developments will focus a huge consumption of semiconductor devices, and they should meet those demand internally. Now, what is fabless design? As it mentions that fabless means we don't require laboratory. Remember, semiconductor is a very complex field and it requires a lot of expertise. Before fabricating a device, what we do, we virtually simulate this device. Before fabricating a device in a laboratory, we develop the device, we test the device, we check the functionality, and once we are satisfied, then we send our design to a lab for fabrication. All these steps are done using computer-aided tools. In engineering, we call them softwares. There are big companies who are making these softwares like Cadence and Mentographic. And BTech students, they are supposed to learn these CAD tools. Because we design a device, semiconductor device, of course, using these CAD tools. Because the complexity of the devices are immense. So here our task is to simulate its functionality, to simulate its designing, to simulate its power consumption, to simulate its operation. And all these things are done using computer designing, and sometimes we also call them as virtual designing. So in virtual designing, we do not need fabrication. Once we are satisfied with our virtual designing, we send these virtual designs to the fabrication lab. And these fabrication labs are situated outside India. For example, Taiwan, China, Europe, Israel, USA. But from the job point of view, India is excellent destination for fabless designing. In Bangalore, in Hyderabad, there are a lot of companies, lot of startups which are working in the field of fabless designing. I mean, someone who is working in the field of electronics engineering or electrical engineering or computer engineering, and if they are good with CAD tools and they know and they want to work in VLSI field, they will realize that VLSI field is a very stable and growing field. It is a pure technical field. Nobody will steal your job after 5 years. In computer, the problem is if a new language is there, then the old skills are lost. But in the field of VLSI or semiconductor devices, over a period of time, you grow again and again, and you learn a lot. So India is quite good in a fabless designing, but the focus of the government is to develop our engineers, our students, our technicians, our teachers in the field of manufacturing. And that is the goal of this government, to bring private partnership and to establish manufacturing labs throughout the country. Now, here are some of the manufacturing companies worldwide. Again, you will see that Qualcomm, we all know about the Qualcomm. We might have here salaries of various engineering college, 1.1 crore, 50 lakhs, 45 lakhs. So who are companies? Who are those companies paying so much money? Yes, these are the companies. TCS and Infosys are not paying so much money. Qualcomm, Broadcom, Nvidia, MediaTek, AMD, and I have taken only 5 top companies. If I go for the list, there are 50, even Intel is there. But the important point is this: India is nowhere, either USA or Taiwan. And you can see the revenue. There's some top 10 labs, manufacturing labs. You can see that in 2017, 2018, 2020. What you see that Samsung, Intel, TSMC, it is a Taiwanese company. Again, you will see that not a single company belongs to India. Well, Intel had a design center in India, and they have opened one design center in 1994. But in last 20-25 years, they did not open any manufacturing center in India. For example, Apple is in India, but Apple is not manufacturing in India. Samsung center is there in Bangalore, but they are not manufacturing in India. Similarly, Micron, Broadcom, Qualcomm, TI, even TI is in India. Toshiba, our engineers are working in these countries, even in India, but they are all working in the field of fabless lab, which I discussed earlier, where you need to learn what is computer-aided designing, what is software, all those things. But not a single company is working in the field of manufacturing. So you have to import your semiconductor devices outside India, and we are losing precious foreign exchange. So our focus is, so you can say that this is a relatively new field nowadays, because we are entering in the field of semiconductor manufacturing, which was neglected earlier. But nowadays, this field has become a focus of area, and that is why this webinar. So people talk about AI, people talk about IoT, people talk about drone technology, people talk about everything. But people should focus in this field also. This is a pure hardware designing field. And we are going to, India is planning to open fabless manufacturing labs in India. And this is a field which will provide immense job to our engineers. Of course, not in 2-3 years, but after 5 years, we will see that a flux of engineers requirement in the field of manufacturing. That is why Government of India wants to create an ecosystem where we will have a lot of engineers who can work in this field. Semiconductor device is not a field where you will train overnight. It is not like a computer designing, computer field where you will learn a language and you will be able to work. No. Here it will take months, not years, in order to enter this field. But once you enter in this field, and after 5 years or after 10 years, if you compare your position with respect to some software, your salary is almost 80% or 90%, even 100% more than your counterpart. The more you work in this field, the more mature and more valuable you become. That is the beauty of advanced engineering. But of course, it is a difficult field. Let me be honest. It is not for everybody, but it is not some field that you cannot enter. Yes, you will have to work on it. Now, let us come to the main question. Why India lagging in semiconductor fabrication? What are the challenges in semiconductor manufacturing? Well, India has done really well in terms of chip design and electronic manufacturing. Electronic manufacturing, don't be confused by electronic manufacturing. Electronic manufacturing means you have chips and you are designing something using those chips. That is electronic manufacturing. What we are discussing, how to manufacture chips in India. That is where we are lagging. So design, well, we have a good designer, we have wonderful designer, we have efficient designer. So why we are unable to develop semiconductor fabrication lab? India has challenges in setting up of semiconductor wafer fabrication. Why? Lack of infrastructure. Anyway. Second thing, it is very difficult because it is a market economy. China, Taiwan, Singapore, their manufacturing is cost effective. Second thing, it requires a massive investment. For example, a computer design center does not require a lot of amount. It needs computer, electricity, and the manpower. But in the field of semiconductors, no, you will have to invest a lot of money. And this money is not in crores, it is in $1 billion. Second thing, this is a very important point. Semiconductor devices, they require a lot of water because you have to purify semiconductor devices. And unfortunately, we do not have massive investment capacity because you cannot invest $5 billion and you will see after 3 years that you are unable to compete in the market and all your $3 or $5 billion are ruined. No, you will have to create a market. See, India has become an open market. So suppose you manufacture mobile chips in India, but if these chips are not cost effective, nobody will buy these chips. That is what this line states. And even if you take a risk, so the risk is huge. $1 billion means 8,000 crore minimum. 2 billion means 16,000 crore. That is a huge investment. And you need millions of gallons of water. There is water in India. These were the problems due to which semiconductor fabrication lab would not flourish in India. But the problem is, if we do not have fabrication lab in India, we will lose billions of dollars, because India is a growing economy. We have young population, demographic benefits, and all that. And all these things will help India to consume more semiconductor. And if India is consuming more semiconductor, obviously our import will rise. And we all know nothing to say about this uninterrupted power supply. We know that what is the situation of power supply in India. So the heart of the issue is that India is still not on the par in terms of the basic infrastructure needed to pursue endeavor in the chip manufacturing space. And this can only be done by the government. It is not possible for a private body to do all this. Now, coming to the job opportunity available, let us talk about technical. If I am an engineer, if I am a technical person, I can join as a design engineer. I can be a circuit designer, layout developer, VLSI testing, and there are more. You can think of a new application of semiconductor devices. There will be a huge demand that is called application engineering. Needless to say, if more labs are coming, we will find jobs in those fabs. But as an engineer, you have immense opportunity in fabless companies. You can join a fabrication lab as a technical expert, or as equipment expert, or as a technical support engineer. Actually, government initiative is that one fabless design center in each district. And it is estimated that in next 5 years, India will require around 200,000 semiconductor engineers, and 2,000 is a huge requirement, because at moment in India we have around 100,000 VLSI engineers. So in coming 5 years, we will have double of this. So growth rate is around 15% and 16%. You can see that it is a huge opportunity. It is a huge job opportunity. For non-technical persons, it will create following job opportunity. If you are a good manager, you can be product manager. Your role is very crucial, because you will have to sell the product. You are making a chip. So how that chip will be available in the market? In which market? You can design an amplifier, but who will buy your amplifier? That is the problem, which will be sorted out by product manager and marketing team. Office support jobs, of course, desk support, of course, it will create computer operate, sales manager. These jobs are always created when we talk about non-technical jobs. In any company, you will require all those things. But if you're a technical person, you can also go in this field. For example, if you're an engineer and you are in a field of product manager, of course, you will have huge demand. If you are an engineer and you are working in the field of marketing, and that too in the field of VLSI, you can see your value. Now, let us come to the main point. What are the initiatives which are taken by the government of India? The first initiative by the government of India was that in 2022, they concluded a big conference. The aim of the conference was to catalyze India's semiconductor ecosystem. First, as a person, as an engineer, I should understand that there is a need for microelectronics, microfabrication. That is why I am giving this seminar. First, I should understand, my students, audience should understand that yes, we need fabrication. Government has proposed a modified program for semiconductors and display fab ecosystem. And government of India has allowed 76,000 crore. It is a huge amount. If India spends 76,000 on education, our institutions will be world level. Anyway, this is a huge amount. Now, see these details. Government will support 50% of project cost on pari passu basis for all technology nodes under a scheme for setting up a semiconductor fabs in India. So obviously, Vedanta has come with a project to open fabrication lab in India. Other companies, for example, Tata, L&T, they are also coming to set a semiconductor fab lab in India. Of course, 50% of the cost will be borne by the government. So if the cost is $2 billion, of course, they will receive $1 billion from the government of India. Government of India will also support 50% of project cost on pari passu basis under a scheme for setting up of display fabs. Display devices. For example, my screen is a display device. LED is a display device. India import will be huge in display field. Apart from this, fiscal support of 50% of capital expenditure on pari passu basis under a scheme for setting up of compound semiconductors. As I discussed in the beginning, gallium arsenide is nothing but a compound semiconductor. So these are the focus area: compound semiconductor, silicon photonics, sensors, and semiconductor facilities in India. Apart from this, Government of India is also focused on discrete semiconductor. So Government of India is very much focused on the SCL, which is situated in Mohali. And this is overtaken by the ISRO. And I have visited this lab at several times. Students from my university, they visit this lab. We have memorandum MOU with this lab. And Government of India is giving a lot of money to this lab to develop itself. We can see the whole detail by visiting this site. Government of India has made this METI site, and you can see about the semiconductor development if you want to see. Now the natural question is where to learn these skills. So who will tell you these? Which is the field? There's a field where you can study. So I have mentioned some of the field. For example, AICT, All India Council of Technical Education, has mandated that engineering institutions should learn course in electronics engineering with this name. I have seen some of the triple IT like triple IT Manipur and some of the other institutions. They are running a course BTech Electronics and Communication Engineering specialization VLSI. These are the new courses. So government institutions and other private institutions are already aware of the developments, and they are coming with these specializations. Apart from that, if you are studying in the field of electronics engineering or electrical engineering or computer engineering, you can go for minor specialization in the field of VLSI design. That is also available, and these are the mandate from the AICT. Or if you are a normal BTech student from the electronics, electrical engineering, yes, of course, this field is for you. Or you can go for higher studies in the field of VLSI, microelectronics, circuit designing. All IITs and IITs, they have these courses. Apart from this, we have a number of specialized training centers. I have seen many centers in Hyderabad. They give course for 6 months. CTEC also runs course in the field of VLSI. So one can pursue course in VLSI designing in CTEC and can enter in this field. PhD can be done in this field. And the good news is that even MSc electronics students can enter in this. As I pointed out earlier, that 1.5 lakh design engineers are required in coming years. So the question is whether we are ready or not. So with this, I will like to finish my presentation, and that is all from my side. I hope my webinar would be of some help to the audience. Thank you from my side.
What a wonderful knowledge given by you, sir. I hope our audience learned many new things from this session. Once again, I would like to thank you for joining us and sharing your experience, your precious time and knowledge with us. Sir, there are few questions which our audience wants to be answered. So,
Okay,
with your permission, shall we?
okay, madam. Okay, go ahead.
So, the first question is how semiconductor will help the environment?
Well, that is very good question. I give you an example. Did you notice that I had talked about the display devices? That the why government of India is focusing on the display devices. For example, take the case of LED, light emitting diode. You see, you know that in our houses we are using LED bulb, LED tubes, and everywhere we are using LED. And you will be surprised to know that LED are good for the environment. Our bulbs are not good for the environment because they produce heat. Semiconductor devices are highly environmental friendly. Semiconductor devices by nature, they do not pollute the environment. That is the beauty with this branch and this semiconductor. For example, your mobile phone does not pollute the surrounding. So semiconductor devices, display devices, these are the future because they are highly environmental friendly. Good. Next question, madam.
Thank you, sir. And the next question, one more question is there. And the question is, what is the difference between fabless and foundry?
See, fabless foundry. Foundry uh, in VLSI engineering in semiconductor devices, we talk about foundry is that place where we actually fabricate, we manufacture the semiconductor device. For example, if you open your mobile phone, you will find a chip inside this mobile phone. So this chip will be fabricated somewhere. That place is called foundry. So manufacturing center, lab, foundry, all are same. And fabless means we are designing, we are designing the concept, we are evaluating the concept. We are not fabricating. So this is the difference between the fabless and the foundry. I hope it is clear.
Thank you, sir. It was very effective for our audience. That was a very good piece of advice. Thank you for answering this question.
No.
Now,
Someone has raised the hand. I don't know how to. I don't. Someone has raised the hand. I don't know how to handle this. Thank you, sir. Okay. Someone has raised the hand. I saw the hand. I don't
yes,
know how
sir.
to. I don't know how to. Okay, there are some
Yes,
questions
sir.
in the chat
Someone
also.
is,
One question is, what are by Abhishek Kumar? What are challenges that we are facing to become self-dependent, and how can we overcome from this? Self-dependent means what? Yeah, are you want to say? Do you want to say self-dependent in the field of semiconductor? So if you talk about semiconductor, I have discussed the challenges which we are facing in my slides. It is infrastructure, it is a huge investment, lack of water. But in my opinion, the main thing is that there is a time. There is a time. Now we cannot ignore semiconductors simply because the import bill is rising very fast. So the self-dependent can be done by manufacturing inside India. That is what India is going to do. Make the concept of Make in India. Someone
thank
has
you,
raised
sir.
the hand. I don't know. I wish
I
India should
think
be number three at the production. Of course, I also wish that should happen in my life. Thank you. Uh, until what time is the webinar? Okay, it is almost finished. Same question. What is the difference between fabless and foundry? I have told you, sir. Okay, we have discussed about the environment. It is highly environmental friendly thing. Okay, and okay, it is okay. How to raise hands? Someone has raised the hand, but I don't know how to uh, allow him to
see.
speak. Can you can you give permission to all to speak for 5 minutes? All audience to speak.
Yes, sir. We can ask them if you want. They all can unmute themselves if they want to ask.
Just unmute, just allow them to unmute. Maybe some of them might be interested in asking some question. I think, I don't know, but I think Resi M. Salubo had raised the hand. That is what I think. Just give her permission. Or him.
He's removed his hand because I think his question is clear.
Okay. Then not a problem. Just give one time permission. If anybody wants to ask some question openly, he can ask. Actually, this field is very wide field. When I teach my students, they also ask a lot of questions. If some question is in your mind, you can ask.
So they can ask in the chat box. If anyone want to ask any question, you can ask in the chat box.
Okay, I can see some question. Where is feed? Okay, yes, please. Thank you, Resi. Drop question in chat. Okay, not a problem. Send reply. Okay. I think there's no question. I think that is okay. They're asking for feedback form. Okay, that you can do. Okay, I forgot to add my detail. So one to email my email ID. This is my official email ID. If you want to ask anything, you can email me at this email. Is it okay, Ansika?
Yes, sir, it's okay. They can ask it personally to you also.
If anybody has any question, they can forward to Ansika, and Ansika can forward to me, or you can directly forward it to me.
Yes, sir. So now I want everyone to kindly open their camera for snapshot.
Okay.
Once again, I will request everyone to open their camera. Again, thank you all for attending today's webinar. And if you have any additional questions, you can contact us by email or telephone. We are very happy to provide additional support to you, and feedback link is being already added in the chat box. Please fill the form within 6 hours. Thank you so much for cooperating. So stay connected to us for new learnings. Anshika Kumari, your host for the day, signing off. Have a wonderful day. Thank you everyone for joining us.
Okay. So should I leave now?
Yes, sir.
Okay, Ansika. So it is 7 p.m. Okay, I will like to go my home. So I have given email. If you have anything, you can call me. Okay, no problem.
Okay, sir.
Okay, thank you. Thank you for the time.
Thank you.